All right, we'll be picking up where we left off here in, I believe it's 2.1. All right, so we stopped, I believe, at number 19. Now I was going to do number 21 next. So number 21 says if we have a function f of x equals 3x squared minus x cubed, find f prime of 1, and then find the equation of the tangent line to the curve y equals 3x squared minus x cubed at the point 1, 2. So they kind of confuse you by writing out, first saying f of x is this, and then say find the equation of the tangent line to the curve y equals this. It's the same curve. So really we want to know the equation of the tangent line to this curve at this point. So we first need to figure out what the derivative at 1 is, because that's equivalent to the slope of the tangent line at that point. So this will be equal to limit, I'm going to use the h one, h goes to 0, f of a plus h minus f of a all over h. And for us in this problem, a is 1. So we get f of 1 plus h minus f of 1 all over h. And now we get to plug 1 plus h into the function wherever we see an x. So here and here. So we'll have 3 times 1 plus h, that quantity squared, minus 1 plus h cubed. And then minus, right here, f of 1. So let's plug 1 in real quick and see what we get. We should get 2 because that's the point on the curve, but I'll just verify. 1 in here, that gives me 3. 1 here, 1 cubed is 1. 3 minus 1 is 2. So yeah, we get 2 there. So this is 2 all over h. And now I get to go and simplify this. So this will be equal to, I really think I prefer to work here, right in the middle. So we have equals limit h goes to 0. All right, I'm going to expand this out, 1 plus h times 1 plus h. So I have 3 times 1 plus 2h plus h squared. That's this. Minus, and then 1 plus h cubed. If you did that, you get 1 plus 3h plus 3h squared plus h cubed. And then we still have minus 2. Then all of this over h. I'll distribute the 3 through, I'll distribute the negative sign through, and I'll clean it up. So limit h goes to 0, 3 plus 6h plus 3h squared minus 1 minus 3h minus 3h squared minus h cubed minus 2. And then all of that over h. All right, and I'm hoping that everything's going to go away except stuff that has h's in the numerator. So if we do 3, take away 1, take away 2, that's gone. And everything else has an h. So equals limit, h goes to 0. Let's see how many h's I have. 6 h's, take away 3 h's. That leaves me with 3h. Okay, I've done that now. H squared, 3h squared minus 3h squared. Oh, those are actually gone. And then I have minus h cubed. All of that over h. Factor an h out of the numerator. So h, and then 3 minus h squared. And then over h. Cancel. Let h go to 0, and that goes away. We get just 3. So the slope of the tangent line to this curve at the point 1, 2 is 3. So now to come up with the equation of the tangent line, I use y minus y1 equals m times x minus x1. So y minus 2 equals m, which is 3, times x minus 1. And then y minus 2 equals 3x minus 3. And add 2 to both sides, y equals 3x plus minus 1. There we go. All right, that's it for number 21. 23, very similar, but the algebra in that one's kind of ugly, so I think I'll work through it. Number 23. They define a function capital F of x to be equal to 5x over 1 plus x squared. And they want to know what f prime of 2 is, capital F prime of 2 is. So what's the slope of the tangent line at 2? And then they want to know the equation of the tangent line at the point 2, 2. So the slope of the tangent line at 2 is going to be f prime of 2, which is by definition limit h goes to 0, and then it's going to be capital F of 2 plus h, that's a plus h, minus capital F of a, which is f of 2, all over h. That's just our definition, which is limit as h goes to 0 of, let's plug 2 plus h in for x, here and here. So that's going to be rather complicated. 5, and then I'm plugging in 2 plus h over 1 plus 2 plus h squared. Then subtract from that f of 2, and if I plug 2 in here, I get 10, and then 4, and then plus 1 is 5, so 10 divided by 5 is 2, and that matches up with this. Most likely on the test, I won't give you the point. You're going to have to come up with that point yourself, but you can see all I'm doing is plugging 2 into this. So minus 2, and then that entire thing divided by h. All right, this one's weird. I have a complex fraction, right? So what I'm going to try and do is get a common denominator. So I think I'll rewrite this 2 as 2 over 1. So my common denominator is going to be this. So I need that to be over here on top and bottom. So I have to multiply, unfortunately, by that entire nasty thing. So I'm going to multiply this by 1 plus 2 plus h squared on the bottom, and then 1 plus 2 plus h squared on the top. And then they'll have the same denominators. And then I can put them together. So my next line will be the limit as h goes to 0 of this numerator minus that numerator. So 5 times 2 plus h, it's this, minus 2 times all that, 1 plus 2 plus h squared, all of that divided by my common denominator, which is that common denominator, 1 plus 2 plus h squared, but then all of that divided by h. And I get to clean up that numerator. So I'm going to distribute 5 through. I'll distribute negative 2 through, but I've got to figure out what that is first. So maybe I'll do that right up here. So we get 10 plus 5h minus 2, and I'm gonna do this first. 1 plus, when I square this, I should get 4 plus 4h plus h squared. Then all of this divided by my common denominator. Then all of that divided by h. Now I can pass this through. Also notice these two together, that's a 5. So shorten up my life of working on this a little bit by just going 10 plus 5h. Okay, distribute. Negative 2 times 5 is negative 10. Hey, look, those 10s are going to cancel. Negative 2 times that, that's negative 8h. Negative 2 times that, that's negative h squared. And that's all over the common denominator. Don't forget this thing. Then all of that divided by h. And I'm hoping everything's going to cancel except h's up here. So 10, 10, gone. And then these two can come together. That gives me a negative 3h. And I'll have minus h squared still. All right, so I have negative 3h minus h squared over my common denominator, all of that over h. And notice on the numerator, these each have h, so I'm going to factor an h out. And I think for this one, I'll do it, since it's a complex fraction, I'll do that h on the bottom as h over 1. And on my next line, I'll write h factored out, negative 3 minus h over my common denominator. And then this h over 1, I'm going to flip it up as 1 over h. And these h's will cancel. And now I let h go to 0. So if that goes to 0, it's gone. I just have negative 3. And then I have 1 plus. Now if this is 0, this is just a 2. 2 squared is 4. So 4 plus 1 is 5. So negative 3/5 is my slope of my tangent line. So now the equation, y minus y1 equals m, negative 3/5, times x minus x1. And then you could solve for y if you wanted to. All right. Let's go to 25. So 25. We give you this function 3x squared minus 4x plus 1. And they ask you to find f prime of a. So we want the slope of the tangent line at a, but they're not going to tell us what a is, which means we need to get a general answer. And so I'm going to have to use the definition f prime of a equals, now I haven't used the other one in a while. Let me use the other one. Limit as x approaches a of f of x minus f of a over x minus a. So let me just try this one. So this equals limit as x approaches a of f of x, which is that function with x plugged in, which is just itself, minus, now be careful, f of a is that function with a plugged in, but we're subtracting it. So subtract 3a squared minus 4a plus 1, and all of that over x minus a. And now I will distribute that negative through. 3x squared minus 4x plus 1 minus 3a squared plus 12a minus 1 all over x minus a. Now, because this is a different formula, I don't want the h to cancel. I actually want x minus a, the entire factor, to cancel. I do notice that these 1's go away. And everything else I have there, I may be able to do something with. So let me try this. Limit x approaches a. Yeah, this is going to be a little messy. I need an x minus a to cancel, so let me get this x squared and a squared next to each other. 3x squared minus 3a squared. And then I still have minus 4x plus 12a all over x minus a. And notice that on this first two terms, we're almost going to do like a grouping here. On the first two terms, I can factor out a 3. So I have 3, then I have x squared minus a squared. That look familiar? Then over here, I'm going to factor out a -4 from those. -4, and I'm left with x minus a. And that's nice because it looks like I'm getting closer to being able to cancel the x minus a, except I would need an x minus a here and here to be able to cancel it all 3 places. So I notice that's a difference of squares. So this becomes 3x plus a times x minus a minus 4 times x minus a all over x minus a. And now at this point I can cancel this x minus a because it appears here, here, and here. So you could imagine just pulling an x minus a out of the top and then it would cancel, but I'm just going to go and that leaves me with limit as x approaches a of 3 times x plus a, that's this piece, minus 4. And now if I let x turn into an a, this turns into an a plus a is 2a. 2a times 3 is 6a minus 4. So 6a minus 4. That's it. You should try 26 on your own. Well, you know what? I think what I'd like to do is I'd like to do this problem with the other formula just to illustrate the difference. If I do the other formula instead, then this would have been f of a plus h minus f of a all over h. So let's see if this one would have been any easier. If I plug a plus h into the function, I get 3 times a plus h squared minus 4 times a plus h plus 1. But then I have minus f of a minus, and then f of a would be 3a squared minus 4a plus 1. But then all of that just over h. And now limit, h goes to 0. All right, if you expanded this out, you could, do that, and then you distribute a 3 through. You would get 3a squared plus 6ah plus 3h squared. That would be this. Now distribute a -4 through, -4a minus 4h, and then plus 1. And then distribute your negative through, -3a squared plus 12a minus 1. All of that over h. Yeah, I think this way's a lot easier. Here's gone. 1's gone. Yes, yeah, that looks good. Everything that's left has an h. Oh wait, 12a. Hold on a second. Missed something up here. Plus 1, 3a. I'm missing something obvious here. Oh, right here. Sorry, when I did this 12, I saw the 3 and brought it over. It was -1, so that just plus 4a. Okay, that's good. These go away. All right, now, this is going to be equal to the limit as h goes to 0 of, okay, since everything has an h in it, right, everything that's left has an h in it, I'm just going to pull an h out now. And that would have left me with just 6a here. And then plus just 3h. And then here just minus 4. And then all over h. The h's cancel. And now when you let h go to 0, that goes away. And you're left with 6a minus 4. Same answer. I like that way a little better. And actually, this is probably going to be the way that we do most of our limits from here on out. We'll focus a lot more on this formula. All right. Next problem. (27). Let me see. 27 looks a lot like something I've done before, but yeah, I'm gonna stick with it. I'm gonna do it. 27. f of t equals 2t plus 1 over t plus 3. I want to know f prime of a, which is the limit as h goes to 0 of f of a plus h minus f of a all over h, which is limit h goes to 0. Okay, plug a plus h in here, right there and right there. So we get 2 times a plus h plus 1 over a plus h plus 3. Now minus, now just plug a in. You get 2a plus 1 over a plus 3. All of this over h. And I have a very complex fraction here. I need a common denominator, which should consist of both this piece and this piece. So I'm going to multiply the top and bottom of this one by a plus h plus 3. And I'm going to multiply the top and bottom of this one. I'm going to be kind of out of room here, but by a plus 3 over a plus 3. And keep in mind, this has to be in parentheses right there because it's like two pieces. Same with this, parentheses right there. Oh, nasty. So here's where I'm at. Limit, h goes to 0. Now I'm just going to write out what we have. We have a plus 3 times 2 times a plus h plus 1. Minus, because of the minus, this times this, so 2a plus 1 times a plus h plus 3. All of this over my common denominator, which is a plus h plus 3 times a plus 3. All of this over h. And if that doesn't look ugly, well, you're not alive, I guess. All right. All right, how do you want to go about multiplying this out? My goodness. We have so many different options, algebra, so we can do so many different things. How about I do this? Just to start, this right here, this little 2, let me pass that through. That would become a 2a, and this would become plus 2h. So change that to 2a plus 2h. There we go. Now I'm going to multiply a binomial times a trinomial, so I'm going to go a through first. After I'm done with that, I'll pass the 3 through. I should get a total of 6 things here. Limit h goes to 0. Okay, a times 2a is 2a squared. A times 2h is 2ah. A times 1 is just a. Plus 3 times 2a is 6a. 3 times 2h is 6h. 3 times 1 is 3. All right, that's it for that first one. Then I have to do this one. Here, 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 here. And whatever I get, I'm going to subtract. So every single one of these, I'm going to change the signs. So 2a times a is 2a squared, but I'm subtracting it. Then 2a times h is 2ah, but I'm subtracting it. And then 2a times 3 is 6a, but I'm subtracting it. Now the 1. 1 through here is a, but I'm subtracting it. 1 through here is h, but I'm subtracting it. And then negative 3. Whew. All of that over the common denominator. All of that over h. And I'm really hoping that everything goes away upstairs except for the h, an h somewhere in all things. So that 2a squared better cancel because it doesn't have an h in it. So here, 2ah minus 2ah, good. A, that better go away. Here we go, a. 3, I just noticed that, 3 and negative 3. 6a, negative 6a, and positive 6a. Man, there's a lot of stuff going away. Man, the only thing left on top is 6h and minus h, which is just 5h. 5h on top over the common denominator. All of this over h, but I'm going to rewrite that. H over 1, I'm going to flip it up and say times 1 over h. And that h cancel. Once they cancel, I let h go to 0. When I let h go to 0, just that goes away. And so everything else is still there. You have the 5 up top. You have just a plus 3 times another a plus 3. So this is just 5 over a plus 3 squared. There it is. Whew. All right. I like it. What is that from? Where have I heard that from? I like it. So I've already had some students make some comments about the fact that I talk to myself in here. You know who you are. But I'm sitting in this room by myself with calculus problems. It's hard not to go crazy, I guess. All right, here we go. X to the negative 2. Now remember, this is just 1 over x squared. Okay, let's not make this more complicated than it has to be. Negative exponent, drop it down. All right, well, if I want to know the derivative at a, we just do limit, h goes to 0, f of a plus h. I'm trying not to write that. F of a plus h just means I'm going to plug a plus h into that. 1 over a plus h squared minus f of a, which is just a into that, and all of that over h. You get a common denominator here. I'm not going to work this one all the way through. Common denominator, you have to multiply top and bottom here by a plus h squared over a plus h squared. And then over here, a squared, and then go through and do your thing. That one's going to work out pretty clean. At the end, you should get negative 2 over a cubed at the end. $29. Yeah, this will be my last one. Although I really like 30. 29. One minus 2x. So the derivative at a is the limit as h goes to 0 of f of a plus h. So I plug a plus h in that. Be careful. 1 minus 2 in parentheses a plus h. Then minus, I plug a into that. So f of a is square root of 1 minus 2a. Then all over h. And immediately you should be thinking conjugate, because you see two radicals there separated by subtraction. We can come in here and introduce root 1 minus 2 times a plus h plus root 1 minus 2a, and I do the same thing on the bottom. And remember, when you do the one on the bottom, you're not going to multiply it through here by this h. You're not going to try and force it in there. You're just going to leave it out there by itself. But this one on top, you will have to FOIL it out. But we know because it's a conjugate that the middle terms will go away. So we just have to worry about the outside. So what is this times itself? Well, the root and the root go away. You're just left with 1 minus 2 parentheses a plus h. And then when you do the middle ones, they go away. The last ones, this times this, the root goes away, but positive times negative is negative. So you're going to have negative of whatever was under there, 1 minus 2a, and you have to have that in parentheses, over h times, and I'm not multiplying this, all this junk, square root 1 minus 2 times a plus h plus Square root of 1 minus 2a. And I know for a fact the numerator should clean up. All right. I'm just going to write above this what this is. When I distribute through, I get 1 minus 2a minus 2h, and then when I distribute here, I get plus 1 plus 2a. And so cleaning this up, let's see, just the 2a's go away? Oh no, that was a minus 1. Apologize. Minus 1 plus, so minus, and that means those 1's go away also. Even better. All I'm left with is negative 2h on top. And then the bottom is h times this thing, square root 1 minus 2 times a plus h plus root 1 minus 2a. And these h's cancel. And now I can let h go to 0. And when I do, I still have a negative 1 on top. And on the bottom, if h is 0, then this is just a. So this becomes 1 minus 2a under a root. And over here, plus another one of those 1 minus 2a's. Now notice it's addition, not multiplication, so I can't put those together like just make the root go away. It's just like you have an apple plus an apple, you got 2 apples. So you should get negative 1 over 2 square roots of 1 minus 2a. There it is. All right, number 38. They want you to read that, then they want you to go to this graph, and they just want you to estimate. They have a curve, and then they have a tangent line they draw for you. They want you to estimate the slope of that tangent line. So just try, the best you can to figure out what the rise over run is on that, and that's an approximation of the slope of the tangent. And then on 47, it's the same sort of thing. Those I'll just leave to you. I think that's good enough. All right, that's it for 2-1.